Hey, this is Noggs and welcome to Noggs House. Today we're talking about the Mammal Takeover, the incredible story of how our furry ancestors survived the asteroid that killed the dinosaurs and eventually led to us. This is a tale of destruction, survival, and opportunity. It shows how one cataclysmic event completely changed the course of life on Earth. Let's dive in. We talked last time about the asteroid that ended the age of dinosaurs. Now let's look at what happened in more detail. About 66 million years ago, an asteroid between 10 and 15 kilometers wide, that's about 6 to 9 miles, slammed into what is now in Mexico near a place called Chicxulub. This wasn't just any impact, it was one of the most catastrophic events in Earth's history. When the asteroid hit, it released more energy than billions of nuclear bombs going off at once. The impact created a crater over 150 kilometers or 93 miles wide. It triggered massive earthquakes, set off volcanic eruptions, and sent huge tsunamis racing across the oceans. But that was just the beginning. The real killer was what happened next. The impact threw enormous amounts of debris into the atmosphere, dust, ash, and especially sulfur aerosols. Tiny particles of sulfur compounds suspended in the air. These particles spread around the entire planet, creating a thick blanket that blocked out the sunlight. Scientists call this an impact winter. For over a decade, that's more than 10 years, the world was plunged into darkness and freezing temperatures. Imagine living in a permanent twilight or darkness where the temperature drops way below freezing even at the equator. Without sunlight, plants couldn't do photosynthesis. When the plants died, the herbivores that ate them starved. When the herbivores died, the carnivores that ate them starved too. Food chains collapsed from the bottom up. This global darkness was the main mechanism that caused the mass extinction. The extinction event wiped out about 75% of all species on Earth, including all non-avian dinosaurs. Remember, birds are avian dinosaurs and they survive. But why did dinosaurs go extinct while other animals made it? Well, ironically, the very thing that made dinosaurs successful, their large size, became a fatal vulnerability. Big animals need lots of food. A full-grown Tyrannosaurus Rex probably needed to eat hundreds of pounds of meat every week. When food would become scarce, these giants couldn't find enough to survive. They also couldn't hide easily. There were no burrows big enough for a multi-ton dinosaur to wait out the impact winter. Their size, which had helped them dominate for 186 million years, became their downfall. So how did mammals make it through when dinosaurs didn't? Well, mammals had several key advantages. First was their small body size. During the age of dinosaurs, most mammals were tiny, about the size of mice or rats. Some were a little bit bigger, maybe like a small dog or a rabbit, but nothing compared to dinosaurs. Small body size meant they had lower calorie needs. A mouse-sized mammal might only need a few seeds or insects per day to survive, while a dinosaur needed tons of food. Small animals could also access protective burrows. They could hide underground where it was warmer and safer, waiting out the worst of the impact winter. This advantage of calorie efficiency, needing less food to survive, was absolutely crucial. Another huge advantage mammals had was dietary generalism. That's a fancy way of saying they weren't picky eaters. Many early mammals were omnivores. They ate both plants and animals, or insectivores. They ate insects. This flexibility meant they could survive on whatever was available. When big plants died, they could eat seeds, nuts, roots, or fungi. They could eat insects, worms, or other small creatures. They could even eat detritus, dead and decaying organic matter. Specialists, animals that only ate one type of food, were in big trouble if their food source disappeared. But generalists could adapt and find something else to eat. This trait of dietary flexibility was a lifesaver. Mammals had even more advantages in their physiology, how their bodies worked, that helped them survive and recover. They were warm-blooded, which means they could regulate their own body temperature. This was super important during the impact winter when temperatures dropped. Cold-blooded reptiles would become sluggish and unable to function in the cold, but warm-blooded mammals could stay active. They had fur, which provided insulation and helped them stay warm, and they had faster reproduction rates compared to large dinosaurs. Mammals could have multiple babies in a year, while big dinosaurs took years to reach maturity and reproduce. This meant mammals could bounce back faster after the extinction. These physiological advantages provided critical resilience, the ability to recover from difficulties, and helped mammals not just survive but thrive once conditions improved. With the dinosaurs gone, a huge ecological vacuum opened up. There were suddenly lots of empty niches, roles or positions in an ecosystem that no one was filling. Mammals saw their opportunity and seized it. They underwent rapid adaptive radiation. Adaptive radiation is when one group of organisms quickly diversifies into many different forms to fill available ecological roles. Within a few million years, mammals went from tiny rat-like creatures hiding in the shadows to the dominant land animals. They diversified into countless different forms. Some became grazers eating grass, others became browsers eating leaves from trees. Some became predators, some went back to the water and became whales and dolphins, and some took to the air and became bats. Mammals also increased dramatically in size. While the biggest mammals during the age of dinosaurs were maybe rabbit-sized, after the extinction some mammals grew as large as modern elephants or even bigger. This was mammals' moment, and they made the most of it. Among all these diversifying mammals, one group is especially interesting to us: the primates. Primates are the group that include monkeys, apes, and humans. The earliest primate ancestors emerged remarkably quickly after the extinction. Within just 100,000 years of the asteroid impact, small arboreal omnivores, arboreal means living in trees, appeared. These little creatures were adapted to life in post-extinction forests. They had grasping hands and feet for climbing, forward-facing eyes for judging distances when jumping between branches, and they ate a varied diet of fruits, insects, and leaves. They weren't quite modern primates yet, but they were on their way. These early primates did well in the recovering forests, and they continued to evolve and diversify. The journey from these early tree dwellers to us is a fascinating story that spans 66 million years. During the Eocene epoch, about 56 to 34 million years ago, true primates evolved with even better grasping hands and more advanced vision. During the Miocene epoch, about 23 to 5 million years ago, apes appeared. These were larger primates without tails that could move through trees using their arms. Then came the hominin lineage. Hominins are humans and our closest extinct relatives. The key innovation was bipedalism, walking upright on two legs, which freed up our hands for using tools. Our brains also grew larger and more complex, giving us advanced cognition, thinking, reasoning, and problem-solving abilities. This led to language, culture, art, and technology. Eventually, about 300,000 years ago, modern humans emerged in Africa. From tiny tree-dwelling insect eaters to a species that can contemplate the universe and write about its own history. That's quite a journey. And it all started because our mammalian ancestors were small and adaptable enough to survive that asteroid impact 66 million years ago. Thanks so much for joining me today at Nog's House. The story of the Mammal Takeover is a powerful reminder of how chance and adaptation shape life's grand narrative. The catastrophic Chicxulub impact was a moment of immense destruction that wiped out the dinosaurs and most other species. But paradoxically, this disaster created the ecological opportunity that allowed small adaptable mammals to flourish and diversify. Over 66 million years, these small survivors evolved into the incredible diversity of mammals we see today, from tiny shrews to massive blue whales, from bats to elephants, and yes, from early primates to us. This evolutionary journey highlights the deep interconnectedness of planetary events in life. A rock from space changed everything, and here we are, able to study and understand what happened. Pretty wild, right? Next time we are going to talk about how our ancestors stood upright and all the advantages and challenges this brought. See you next time.